Hey everyone, so we are going to continue graphing parabolas. We're kind of go back. We're going to do it in a slightly different way, similar to something we did that I accidentally skipped. So, all right, pause and try this problem. In the equation above, a, b, and c are constants. If the equation is true, what is the value of b? So whenever you see a problem, just think, okay, what do I know how to do? Well, here we know how to distribute, right? So let's distribute. 6x squared plus 10x, right? Distribute that, and then we distribute the 3. 9x, and then 15. Combine the middle two together. 6x squared plus 19x plus 15. So what is the b value? The b value is 19. So that's all they were looking for, right? Don't overthink it. Okay, so let's think back before we did vertex form. How do you find the vertex? There's a formula we know. What is it? Negative b over 2a. Good. So if I do negative b over 2a, b is 2, right? Negative 2 over 2 times. There's an invisible 1 in front. So that gives me negative 1. And then it says factor and solve for the roots. So that's something that we did. How do you factor x squared plus 2x minus 3? Oh, wait, I forgot to find the y value of the vertex. All right, so let's plug in to find the y value. Negative 1 squared, 2 times negative 1 minus 3. So that's 1 minus 2 minus 3, which is negative 4. All right, so now factor and solve. So when we factor, what multiplies to negative 3 combines to 2. 1 and 3, where the 1 is negative. So that's x minus 1, x plus 3 equals 0. So x minus 1 equals 0, x plus 3 equals 0. So my roots are 1 and negative 3. That is super ugly. All right, so I got negative 1, negative 4. I have my roots of 1 and negative 3. My y-intercept is negative 3. And my symmetric point is negative 2, negative 3. And notice we could have done over 1, up 1, right? This is my vertex, so over 1, up 1, over 2, up 1, 2, 3, 4. So that is a method still, even though we're looking at it in a different form. Okay. So now, here's what I want you to do. Remember that we talk about the symmetric point, the axis of symmetry, right? So because of the axis of symmetry, right, it goes to the center. Think about 1 and negative 3, right? 1 and negative 3, what's the midpoint between those two? 1, 2, 1, 2. That negative 1 is the middle of negative 3 and 1. Think about from geometry and when you were younger, what are we finding if we're finding the middle? The midpoint, the average. So if we didn't want to find the vertex using negative b over 2a, what we could have done is taken these two numbers, negative 3 plus 1, and just divide by 2. The vertex is exactly in the middle of the two roots. Okay? We're going to use that fact for the rest of these problems. Okay. So we're going to start. What do you think the easiest thing to find is if we have x plus 3 times x minus 5? Do not multiply out. I mean, could you multiply out? Sure, but that's a little silly. So if we set that equal to 0, what do we get? Our roots are negative 3 and 5, right? We just set them equal to 0. X plus 3 equals 0. X minus 5 equals 0, and we solve. So I'm at 1, 2, 3, 4, 5, and 1, 2, 3. So there are my roots. Now, what did we say? What's another way to find the vertex? I'm going to add my 5 and my -3 and divide by 2. 5 and -3 is 2, divided by 2 is 1. So the x value of my vertex is 1. And then we plug in. So I have 1 plus 3 times 1 minus 5. 4 times -4 is -16. That's why I gave you this grid, because we have to go all the way down to -16. So I got a point there. And then my y-intercept. Remember your y-intercept, if you plug in 0, you get -15. Symmetric point, double my vertex, so 2, and then it's the same. So there's our 15. This is a really not well-made graph. Oh well. And then what's the domain? The domain of every single parabola is all real numbers. And then the range, what's the lowest y value? The lowest y value is -16, so it's -16, and then it goes up forever. Right? So this is the method that's the easiest when it's already in factored form. Now, you could always multiply it out, do -b over 2a and all that, but since it's already factored, this is the fast way to do it. All right. So I want you to pause, find your roots, find your vertex, and then stop. All right, so my roots, x minus 3 equals 0, so x equals 3. X plus 1 equals 0, so x equals -1. So -1 and 3. So I know actually a lot of you write it as a point. So let's do that. -1, 0, 3, 0. And then what's the middle of 3 and -1? 3 plus -1 divided by 2. A lot of these are 1. That's interesting. So my vertex is 1. Now I'm going to plug in 1 to get my y value. So my equation is -2, 1 plus 1, 1 minus 3. Now you can, feel free, just put that in the calculator. What do you get? I'm going to simplify it since I don't have a calculator on me. So we get 8. So 1, 8. Y-intercept is the exact same thing as we just did, but plugging in a 0 instead. So it's -2, 0 plus 1, 0 minus 3. So that gives us a 6. 0, 6, double my vertex, 2, 6. Okay, so I got 1, 8. I got 0, 6, 2, 6. So there's my parabola. It's a little nicer than that last one. All right, and now write down what's the domain and range. Domain, all real numbers. Some kids like to do -infinity to infinity. And then the range, this one, we have arrows going down, so that's -infinity. And then what's the highest point? 8. You also can write y has to be less than or equal to 8. Okay. This one's a little harder because we're going to have some decimals, but aside from that, it's really not that bad. So I want you to pause and try it on your own. So my my roots, again, set each of those equal to 0. Subtract 4, subtract 7. So we get -4, 0, -7, 0. So we're here and here. And then we need the midpoint. What's exactly in the middle of -4 and -7? -4 plus -7 divided by 2. That's -11 over 2, which is -5.5. Don't overthink it. Grab your calculator. grab your calculator and just plug in. When I did that, I got 2.25. If you got negative, don't forget about that negative in front. All right, now what would the y-intercept be? We're not going to be able to plot the y-intercept. What is it? It's negative 28. 7 times 4 times negative 1 is 0, negative 28. Our symmetric point would be negative 11, negative 28. So we're not going to end up plotting those. So negative 5.5, 2.25. So we're like there. So we don't have much that we're graphing here, but that's okay. All right, that's it. We got those 3 points. All right, domain. Again, all real numbers. All real numbers. Our domain goes from left to right. Left arrow, right arrow, negative infinity to infinity. Our range, lowest, negative infinity to highest, 2.25. Put a bracket because it's a solid dot. Alrighty, try this one. Again, pause it. You can do it. I have confidence in you. Alright, set each of these equal to 0, so we end up changing the sign. So negative 5, 0, and 2, 0. Negative 5 and 2. We're going to add those, divide by 2. Negative 5 plus 2 divided by 2. That's negative 3 over 2. Negative 1.5. And then we're going to plug that into our equation, see what we get. All right, pretty gross. You get negative 7 over 12, which is negative 0.583 repeating. So I like to write down that decimal just because it's way easier to graph, right? I don't know how to graph 7/12, right? So negative 1.5 and then up just about a half. So we're like here. This is going to be the weirdest looking graph. All right, y-intercept. So plug in 0, so 1/3 times 5 times negative 2. And we get, uh-oh, I did something wrong. Oh, I went the wrong way. Negative 1.5, so we're like here. What did I do wrong? I did something wrong. Okay, so I did something wrong with my y-intercept because, not my y-intercept, my vertex x value. I don't know what it is. I typed something wrong in my calculator because it's negative 4. Why is my pen not working? Oops, I'm on eraser, that's why. Negative 4.0083. Ugh, that's so ugly. It ended up being negative 49 over 12. It's like that. It looked like, if you notice, it looks really weird. I'm like, that's like barely a parabola. So use your judgment, you know? Like I was like, I think something's wrong. Okay, so negative 1.5, around negative 4. So we're like around here, right? And now my y-intercept makes sense because I got negative 3.3 repeating. Oops, 0, negative 3.3 repeating. And then the symmetric point would be negative 3, negative 3.3 repeating. Negative 3 and a little bit. Negative 3, negative 3. Okay, this looks better. This looks more normal. Still a little weird looking, but it is what it is. Looks kind of linear. I don't know why. All right, domain, all real numbers. What is the range? So my lowest y value is that negative 49 over 12, and it goes up forever. So infinity. All right, last one. All right, so my roots, I'm going to go through fast. 8, 0, 3, 0. You should do this on your own. This one's very doable. All right, so we got 8 and 3. The vertex, 8 plus 3 divided by 2. That is 11 over 2, which is 5.5. Plug in 5.5. I got negative 12.5. My y-intercept, 0. We get 48. Symmetric point, 1148. Domain, all real numbers again. And the lowest point is negative 12.5. And it's going to go on forever. All right, let's plot this. So I have to go out to 8. Let's make that 8, 4, 3. We need to go down to 12 and up to 48. I want it to look as accurate as possible, so that's why I did that. Okay, 5.5 is like here. So then we have our 8, our 3, our 48. And then because I'm doing just like a sketch, I'm going to label. So this is 5.5, comma, negative 12.5. And this is 11, comma, 48. So whenever you're kind of out there with your drawings, label. All right, that's it.